Okay, we're going to look at parametric equations. Let's just write that down. Parametric equations. Now, a parametric equation is when the x-coordinate and the y-coordinate is given in terms of a different variable. So if I explain that, if I've got a circle, centre of the origin, that's the radius, so imagine that rotating around, and theta is varying as it rotates around. If I actually look at what the y-coordinate is in terms of theta, just think back to your mechanics when you're resolving, that line there, the y-coordinate, will be r sine theta, and the x-coordinate will be r cos theta. So your x and y coordinates are given in terms of a different variable, and that's called a parametric equation. Now it's easy to turn these back to a Cartesian equation. Squaring is always a good strategy, but to square it, what we need to do is to separate out everything from the sine and cos. So y divided by r will be sine theta, and x divided by r will be cos theta. And the reason squaring is such a good strategy for this is because sine squared plus cos squared is always equal to 1. It's a standard identity that you all know. So if we square both of these, y squared divided by r squared is sine squared theta, and x squared divided by r squared is cos squared theta. Then if I add both of those together, I should get 1. Y squared over r squared plus x squared over r squared is equal to 1, which means that y squared plus x squared is equal to r squared. And that's the standard equation of a circle, centre of the origin, which you know from C2. What we're now going to do is look at parametric differentiation. So we're going to look at page 41 of the preparation booklet, question 6. And question 6 says, find dy by dx if x is cos t and y is cos t plus sine t. So the parameter in this case, the different variable, is t. Now there's a simple formula that you need to remember to find dy by dx. And dy by dx is equal to dy by dt divided by dx by dt. Y on the top there, y on the top there. And dy by dt, if I work that out, dy by dt, well, the differential of cos is minus sine t, and the differential of sine is cos, plus cos t, and dx by dt, well, the differential of cos is minus sine t. So all we have to do is divide dy by dt by dx by dt. So dy by dx will be equal to minus sine t plus cos t, all divided by minus sine t. And that can be simplified because minus sine t divided by minus sine t is 1, and cos t divided by minus sine t is minus the cotangent of t. So simplified, dy by dx in terms of the parameter t is 1 minus cot t. And that's how you do parametric differentiation.